Okay, so get this. It takes about 20 minutes
Wow.
to fully annotate a single image for AI training.
Okay.
Like we're talking meticulous outlining over 100 objects per image.
Yeah.
Now imagine doing that for millions of images.
Right,
It's a
yeah.
massive undertaking, right?
Dude.
So that's why today's deep dive is so exciting.
Absolutely.
We're about to explore a world where AI can see and understand images without all that manual effort.
It's truly a paradigm shift in computer vision.
Right.
We're moving away from this incredibly labor-intensive process of hand-labeling images towards a future where AI can learn to segment images on its own.
All right, so let's dive right in.
Yeah.
Today we're exploring unsupervised SAM, or UNSAM for short.
Okay.
We're going to unpack how it works, why it matters, and what it means for the future of computer vision.
I'm excited.
Me too. So the key here is that traditional AI models for image segmentation, like the original SAM, they rely on these huge data sets of labeled images. Think about the SA1B data set, for example.
Okay.
11 million images and over 1 billion hand-drawn masks.
Wow.
That's not only time-consuming and expensive to create, right?
Huge. Yeah.
But it also introduces human bias and limits the amount of data we can use to train these models.
Yeah, absolutely.
So how does UNSAM overcome this hurdle?
Well, UNSAM tackles this problem with a clever two-step process.
Okay.
It's almost like how our own visual systems work.
Interesting.
It starts by using an existing method called Cutler to make initial guesses about the objects in an image.
So it's like quickly sketching out the main shapes in a scene before filling in the details.
Exactly. That's the divide stage. Then it moves on to the conquer stage.
Okay.
UNSAM zooms in on each of those regions and uses a bottom-up clustering method.
Right.
Essentially, it starts grouping similar pixels together, merging them into larger and larger groups.
Okay.
This process reveals a hierarchy of parts within each object.
It's like solving a jigsaw puzzle, right?
Yeah.
You start with the edges and corners, grouping similar colors and patterns, and gradually build the complete image.
That's a great analogy.
I like it.
And what's fascinating is that UNSAM can often detect details that even humans miss.
Really?
The research shows examples where it identifies tiny numbers on a camera screen.
Wow.
Or the delicate curve of an animal's tail, things human annotators might overlook.
That's impressive.
Yeah.
But those initial masks from the divide and conquer stage, aren't they still a bit rough around the edges?
You're right. They're good, but not perfect.
Okay.
And this is where the self-learning magic comes in.
I like magic.
UNSAM uses its own initial output to train and refine its segmentation abilities.
So it's learning from its mistakes.
Exactly.
Okay.
Think of it like practicing a sport or a musical instrument.
Okay.
The more you practice, the better you get at recognizing patterns and perfecting your technique.
Right.
So it's basically using its own output as a stepping stone to become even better at segmenting images.
I love that.
Yeah.
But how does it actually perform compared to the original fully supervised SAM?
Okay.
Does it come close?
The results are truly remarkable.
Okay.
Remember how I mentioned that UNSAM only uses a small fraction of the labeled data?
Right.
Well, get this. Even when trained on just 1% of SA1B's images,
1%.
it achieves performance that's very close to the fully supervised SAM.
Hold on, wait, rewind.
Yeah.
Only 1%. That's incredible.
It is.
Oh.
And not only that, on data sets specifically designed to test part segmentation, like part ImageNet and Pico, UNSAM actually outperforms the supervised SAM by a significant margin.
Oh, wow.
For instance, on part ImageNet, UNSAM scores 51.6% in average recall.
Okay.
While the supervised SAM only reaches 28.3%.
So in those cases where we need to analyze those finer details within objects, UNSAM might be the better option.
Could be, yeah.
It's like it's developed a deeper understanding of how things are structured,
even
without being explicitly taught.
Exactly.
Wow, that's really interesting.
It raises some really interesting questions about the potential of unsupervised learning in AI.
I'm hooked.
Yeah.
But I'm curious, did the researchers stop there? Or did they find ways to make UNSAM even more powerful?
You know, researchers, they always push the boundaries.
Yeah.
They actually developed an even more advanced model called UNSAM+.
All right, tell me more. What is UNSAM+?
UNSAM+ is a fascinating hybrid approach.
Okay.
They combine the human annotations from the SA1B dataset with the self-generated masks from UNSAM.
So they basically combined human insight with the machine's self-learning capabilities.
Exactly.
Clever.
Yeah.
What were the results like?
The results are truly remarkable.
Okay.
UnSAM Plus actually surpasses the original SAM's performance on the SA1B dataset by over 6.7% in average recall. What's even more impressive is that it shows even bigger improvements in detecting small, easily missed objects.
So even though UnSAM can do amazing things on its own, there's still value in incorporating human knowledge into the mix.
It seems so.
It's like a true collaboration between human and machine intelligence.
It really is.
But I'm curious, does UnSAM Plus only excel at segmenting entire images?
Yeah.
Or can it also handle those point-and-see tasks like the original SAM?
Yeah.
You know, where you give the AI a point and it outlines the object.
That's a great question.
Yeah.
And you're in for a treat. UnSAM can handle those tasks too.
No way. So I could point at, say, a cat in a picture, and UnSAM could outline it.
Exactly.
That's so cool.
And here's the kicker.
Right.
Even with a smaller model and less training data, UnSAM Plus outperforms SAM on these promptable segmentation tasks.
Wow.
For example.
Yeah.
It achieves a 69.5% oracle intersection over union score, meaning its mask very accurately overlaps with the true object boundaries.
All right.
That's compared to 68.2% for SAM.
Okay, this is officially blowing my mind.
Yeah.
We've got an AI that can learn to segment images without human supervision, outperform state-of-the-art models, and even do those cool point-and-see tasks.
Yeah.
Amazing.
That's a game changer for sure.
It is.
But of course, no technology is perfect.
Right.
There are still some limitations with UnSAM.
Okay.
And the researchers are very transparent about that in their paper.
All right, let's talk about limitations.
Sure.
What are some things UnSAM still struggles with? Is it just a matter of needing more data?
Well,
or are there fundamental challenges?
One thing the researchers highlight is that UnSAM can sometimes struggle with very complex images.
Right.
Especially those with a lot of repetitive, fine-grained details.
Okay.
For instance, it might miss some leaves in a very dense forest.
Okay.
Or over-segment objects with complex textures.
That makes sense.
Yeah.
Imagine trying to pick out individual blades of grass in a field.
Yeah.
Even for us humans, that's a challenge.
Right.
The subtle differences that we can perceive might still be difficult for UnSAM to distinguish in those cases.
You might, yeah.
But even with those limitations, the potential applications of this technology are immense.
Absolutely.
It's true.
Think about fields like medical imaging, robotics, self-driving cars.
Wow.
The possibilities are truly endless.
I can already picture robots navigating cluttered spaces with ease.
Yeah.
Doctors making faster, more accurate diagnoses.
Right.
And self-driving cars understanding their surroundings perfectly.
Exactly.
The potential impact is huge.
It is.
Wow, we've covered a lot in this first part.
Yeah.
It's been a whirlwind of information.
It has.
What are the main takeaways so far from our deep dive into UnSAM?
Well, I would say, first and foremost, unsupervised AI is no longer a futuristic concept.
Right.
It's here.
It's here.
And it's capable of achieving incredible things.
Absolutely.
UnSAM clearly shows that AI can learn to segment images without requiring those massive, manually labeled data sets.
Right.
And that opens up a world of possibilities for the future of computer vision.
Absolutely. And second, it's not just that UnSAM performs well.
Yeah.
It actually competes with and, in some cases, even surpasses the most advanced supervised models out there.
Yeah.
Especially when it comes to analyzing the detailed structure of objects.
Right. And finally, we need to remember that UnSAM is not just a research project.
Yeah.
It has the potential to truly transform industries and our daily lives in some very tangible ways.
I'm already excited to see where this technology goes next.
Me too.
But before we get ahead of ourselves, let's take a closer look at some of the specifics of UnSAM. And explore what makes it so unique.
It really is a remarkable development, and it makes you wonder what else this technology could be capable of. We've talked about its potential in fields like medicine and robotics, but where else could this lead? What happens when AI can understand the world visually without relying on us to feed it labeled data?
That's a fascinating question. It feels like we're opening up a whole new chapter in the relationship between humans and AI. It challenges our assumptions about what AI can do and how we interact with it.
Absolutely. Instead of simply being tools that we program to perform specific tasks, AI systems like UnSAM are starting to resemble partners or collaborators. They can learn from the world in a way that's much closer to how we do it.
Imagine AI systems that aren't limited by the biases and limitations of human-curated data sets. They could develop entirely new ways of understanding the world, uncover patterns and insights we might never have considered.
It's an exciting prospect, but also a bit daunting. We're venturing into uncharted territory.
It's true. It's like we're exploring a vast, unknown landscape with incredible potential, but also potential risks we need to be aware of.
Well said. It's crucial to approach this new era of AI with both enthusiasm and caution.
Let's shift gears for a moment and delve into one of the most intriguing aspects of UnSAM. Its ability to segment images at different levels of detail. It's not just identifying a car. It's also recognizing the wheels, the windows, the headlights, all the individual parts.
Right. That's one of the things that makes UnSAM so unique. Remember how we talked about the divide and conquer approach? Well, that iterative process of merging pixels doesn't just stop at outlining the object. It creates a hierarchy of parts within the object.
It's like UnSAM is not only recognizing the objects themselves, but also understanding how they're put together, like it's creating a blueprint or a map of each object.
Exactly. And what's remarkable is that it's doing all of this without any prior knowledge of what these objects or their parts are supposed to look like. It's purely based on the visual information it's receiving.
It's almost like it's building its own visual vocabulary from scratch. It's learning to see the world and break it down into its fundamental components all on its own.
The researchers call this multi-granular segmentation, and it opens up exciting possibilities for tasks that require a deeper understanding of objects and their parts.
For instance, in medical imaging, being able to analyze the shape, size, and internal structure of a tumor could be incredibly valuable for diagnosis and treatment planning.
Exactly. And in robotics, imagine a robot that can not only grasp a tool, but also understand how to use it effectively because it recognizes the relationship between its parts.
This multi-granular segmentation ability seems like it would revolutionize so many fields.
It has the potential to be truly transformative.
I'm eager to explore some of those potential applications in more detail, but before we do, I think it's important to acknowledge the computational challenges involved in running UnSAM, especially for high-resolution images. It's a lot of data to process.
You're absolutely right. While UnSAM's performance is remarkable, there are practical considerations. Even with advances in hardware and software, analyzing that much visual data in real time can still be a bottleneck.
So there's a trade-off between the level of detail UnSAM can achieve and the speed at which it can process information.
Exactly. For applications where speed is paramount, like in self-driving cars, there might need to be some compromises, either in terms of the level of detail or the speed of processing.
That makes sense.
Right.
Another area where we need to be cautious is in ensuring the accuracy and reliability of UnSAM's output in real-world scenarios, especially those with high stakes. Even small errors could have significant consequences.
Absolutely. It's crucial to develop robust error detection and correction mechanisms, as well as backup systems that can intervene if UnSAM's output is deemed unreliable. Think about a medical diagnosis or a self-driving car. We need safeguards to prevent potentially harmful mistakes.
Those are all valid points. It highlights the need for interdisciplinary collaboration. Developing and deploying UnSAM responsibly will require not only computer scientists, but also experts from other fields like ethics, law, and social sciences.
I agree. It's a reminder that technological innovation should be approached thoughtfully with a focus on ensuring its safe and ethical use.
Well said. It seems like UnSAM is raising some fundamental questions about what it means for a machine to understand something.
That's a really interesting point. The paper itself touches on this, and it's a topic of ongoing debate in the AI community. If an AI can learn to segment images without any human guidance, without being explicitly taught what objects are or how they're structured, does that mean it's demonstrating a form of understanding?
It's like if it looks like a duck, walks like a duck, and quacks like a duck. But in this case, if it segments images like a human, the results are there. But there's still a sense of mystery surrounding how UnSAM is achieving this.
That mystery is part of what makes this research so fascinating. It's pushing the boundaries of our understanding of both AI and intelligence itself.
This has been an incredibly thought-provoking discussion. So far, we've explored how UnSAM works, its strengths, and its limitations. But what I'm most curious about now are the real-world applications.
Let's dive into that. There are so many exciting possibilities, from everyday tasks to groundbreaking innovations.
I'm ready to be amazed. Where do we start?
Well, let's start with some of the more immediate applications that could impact our daily lives. One area where UnSAM could have a significant impact is in image editing and manipulation.
I can see that. Imagine being able to effortlessly cut out objects from photos and videos or create seamless composites with just a few clicks.
Exactly. And it wouldn't just be limited to professional editors or designers. Anyone with a smartphone or computer could harness the power of Unsam to enhance their photos, create personalized content, or simply have fun experimenting with visual media.
It's like having a virtual Photoshop expert in your pocket. But beyond image editing, Unsam's potential extends to so many industries and fields. What about its potential in e-commerce and online retail?
That's another area where Unsam could be transformative. Imagine searching for products based on their visual attributes instead of just keywords or descriptions.
Instead of typing red dress with floral print, you could upload a picture of a dress you like, and Unsam could find similar items across different online stores. That would be incredible.
Exactly. It could even go further. Imagine virtually trying on clothes or accessories, seeing how furniture would look in your home, or even getting personalized recommendations based on your visual preferences.
Wow, that would completely change the online shopping experience. It would become so much more intuitive and interactive. But let's shift gears and talk about Unsam's potential in fields like medicine and healthcare.
That's an area where Unsam could truly make a difference. Imagine it being used in medical imaging to automatically detect and segment tumors, lesions, or other abnormalities.
It would be like having an AI assistant working alongside doctors, helping them make faster and more accurate diagnoses, personalized treatment plans, and ultimately save lives.
Precisely. And it's not limited to static images. Unsam could also be used to analyze real-time video feeds from endoscopic procedures or surgical robots, giving surgeons valuable guidance during complex operations.
The potential in healthcare is truly immense, but I'm also curious about its potential in other fields like agriculture, environmental monitoring, and even space exploration. Could Unsam be used to analyze satellite images, identify crop diseases, or even help us explore other planets?
Absolutely. The ability to analyze visual data with this level of detail and precision has far-reaching implications.
It seems like there's almost no limit to the potential applications of Unsam, from improving our daily lives to addressing some of the world's biggest challenges.
It's truly remarkable, and it highlights the power and potential of unsupervised AI.
I'm especially fascinated by its potential in robotics. Imagine robots that can not only navigate complex environments, but also manipulate objects with dexterity and interact with humans in a more natural way.
It's a vision that's been a staple of science fiction, but with Unsam, it's starting to feel more attainable. Imagine robots that can assist with household chores, provide care for the elderly, or work alongside humans in factories and other industrial settings.
The possibilities are endless.
Yeah.
It could completely reshape how we live and work.
But it's important to remember that even with all its potential, there are still challenges to address before Unsam can be widely adopted.
Right. What are some of those challenges?
One key challenge is the need for more robust and diverse datasets. While the SA1B dataset is significant, it's still limited in terms of the variety of objects, scenes, and viewpoints it represents.
So we need larger, more comprehensive datasets to train Unsam models that can truly generalize to real-world scenarios.
Exactly. And we also need to ensure the quality of the data we need to ensure it's accurate, unbiased, and representative of the real world.
That makes sense. It's not just about the quantity of data, but also the quality.
Another challenge is the need for more efficient algorithms and hardware. If Unsam is going to be truly ubiquitous, it needs to run smoothly on a wide range of devices, not just powerful servers.
So we need innovations in both software and hardware design to make Unsam accessible to everyone.
Absolutely. These are ongoing challenges,
Right.
but I'm confident that researchers will continue to push the boundaries and find solutions.
I'm excited to see what the future holds. But before we wrap up our discussion of Unsam, I think it's important to take a moment to acknowledge the incredible work of the researchers who developed this technology.
Absolutely. Their groundbreaking research is pushing the boundaries of AI and opening up a world of possibilities.
It's a testament to human ingenuity and the power of collaboration.
Well said. It's a perfect example of how sharing knowledge and working together can lead to incredible breakthroughs that benefit all of humanity.
Now, before we move on to the final part of our deep dive, I want to leave our listeners with a thought-provoking question to ponder. We've seen how Unsam can see and understand images without human supervision. But what if this unsupervised approach could be applied to other senses?
That's an intriguing question.
Could AI learn to hear and understand sounds or even feel textures without our input? What other senses could be unlocked by this technology?
That's a fascinating thought. Imagine AI systems composing music, creating art, or even designing new materials based on their own unique sensory experiences.
The possibilities are mind-boggling.
Yeah.
It's a future that's both exciting and a little bit daunting.
But it's definitely a future worth exploring. So to our listeners, we challenge you to think about what other senses could be unlocked by unsupervised AI and what impact that would have on our world.
Let's take a moment to gather our thoughts, and then we'll delve into the final part of our deep dive into unsupervised SAM.
Yeah.
All right, so we've talked about the potential of unsam across so many fields, but it's important to kind of like take a balanced view, right?
Mm-hmm.
And consider some of the practicalities. Are there any real-world, I don't know, limitations or challenges that might affect how quickly this technology becomes, widespread?
Yeah, I think one thing to consider is that unsam, like any complex AI system, requires significant computational power.
Right.
While it's been designed to be efficient, processing those high-resolution images, especially in those real-time applications like you were talking about, like self-driving cars, could still be demanding.
So the more detailed and granular the analysis, the more processing power is needed.
Precisely. And that means there might be trade-offs depending on the specific application. For tasks that require, lightning-fast responses, there might need to be some compromises in terms of the level of detail unsam can achieve. It's like a balancing act between speed and accuracy.
That's a good point.
Yeah.
Another area we haven't really touched on yet is the data itself.
Right.
Unsam learns from the data it's given, but what happens if the data isn't perfect?
Right.
Could there be limitations based on the quality or availability of suitable training data?
That's a crucial consideration.
Yeah.
If the data used to train unsam is limited, biased, or doesn't accurately reflect the real world, it could affect the model's performance and lead to unintended consequences.
Okay.
It's like learning a language from a textbook that's full of errors. You might end up speaking with a strange accent or making grammatical mistakes.
So garbage in, garbage out, as they say.
Exactly. The quality and diversity of the data used to train unsam is really paramount. Researchers are actively working on creating larger, more comprehensive data sets that are representative of the real world, but it's an ongoing challenge.
That makes sense. It highlights the importance of not just developing the algorithms, but also ensuring we have the right data to fuel them.
Absolutely.
It's like building a powerful engine, but not having enough fuel to make it run properly.
Yeah, data is the fuel that powers AI, and without the right kind of fuel, even the most sophisticated models will struggle to reach their full potential.
This has been an incredible journey, exploring unsam and the world of unsupervised AI. As we wrap up this deep dive, what are some, key takeaways you'd like our listeners to remember?
Well, I think first and foremost, unsupervised AI is here, and it's making waves. Unsam is a testament to the fact that AI can learn and adapt without constant human guidance.
It's a game changer. It opens up a world of possibilities for, automating tasks, analyzing complex data, and creating innovative solutions across various industries.
Exactly. But it's important to remember that unsam is a tool, and like any tool, it has its limitations. Computational power, data quality, and those real-world constraints are all factors that need to be considered.
Right. And as with any powerful technology, responsible development and deployment are crucial. We need to ensure that unsupervised AI systems like unsam are used ethically and for the benefit of all.
Absolutely. As we continue to push the boundaries of AI, it's essential to have open discussions about the implications, address potential biases, and create safeguards to ensure these technologies are used for good.
Well said. This has been a truly insightful and inspiring deep dive into the world of unsam. A big thank you to our expert for sharing their knowledge and insights.
It's been my pleasure.
And to our listeners, thank you for joining us on this journey. We hope you're as excited as we are about the potential of unsupervised AI. Keep exploring, keep questioning, and keep diving deep.